In this video, we will learn how to refer to many of the chemical compounds we'll encounter in chemistry. We'll learn how to write and interpret the notations used in chemical formulas, and we'll learn how to name different types of compounds. All matter is composed of different combinations of atoms that combine in specific ratios to form compounds, which means that there are hundreds and hundreds of chemical compounds that we encounter on a daily basis. If we want to refer to all these compounds and talk about them as scientists, we're going to need some formalized and concrete way to do that so that we're all on the same page. And since all compounds are made of a specific ratio of atoms, it would be helpful if this language that we used referred to the atomic makeup of the compound. For example, let's take a look at a compound that we're all familiar with: water. A molecule of water is always composed of 2 hydrogen atoms and 1 oxygen atom. How should we refer to this molecule besides calling it water? Since we would like some way to refer to the atomic makeup of water, maybe we could use the full names for each element and call it the molecule composed of 2 hydrogen atoms and 1 oxygen atom. But that's a little wordy. We probably wouldn't want to write that out every time water participates in a chemical reaction. Perhaps we could shorten things by using the atomic symbols that we see on the periodic table: H for hydrogen and O for oxygen, which seems much easier to deal with. If we use these atomic symbols for the elements in a compound, we have a way to refer to the type of atoms in a compound. So now we just need a way to refer to how many of each type of atom are in a compound. As we mentioned earlier, each unit of water, 1 water molecule, contains 2 hydrogen atoms and 1 oxygen atom. There's various different things that we could think of to put those numbers in. Maybe using a ratio, or 2H1O, or maybe using superscripts or subscripts. Well, as it turns out, by convention, we use subscripts to indicate the number of atoms. But when we only have 1 of an atom in a compound, like we have with oxygen, we drop the subscript, so that leaves us with H2O. What we've arrived at is called the chemical formula of water. Chemical formulas tell us the type and number of each type of atom that's in 1 unit of a compound. To indicate the type of atoms that are on our compound, we use the atomic symbols, and to indicate the number of atoms in the compound, we use subscripts. Now, what do we do if we have more than 1 molecule of water? What if we have 2? How do we include this in our chemical formula? We could try collectively putting the total number of atoms in our formula, which would give us H4O2. But this could be confusing, since it could indicate a compound that has 4 hydrogen atoms and 2 oxygen atoms. So instead, let's indicate the number of units of a compound that we have in front of the chemical formula. So if we have 2 water molecules, we would write 2H2O. With this knowledge, we know the basics of chemical formulas, but let's discuss some specifics so we can confidently create and name chemical formulas for some of the different kinds of substances we might encounter in chemistry. With our water example, we've been discussing compounds whose atoms bond covalently to form a molecule. These compounds are composed of non-metal elements, which are primarily found on the right-hand side of the periodic table. Not all molecules have common names like water, so we need some way to name them based on their atomic makeup. In this video, we'll be focusing our attention on how to name molecules that are composed of 2 elements. The less electronegative element in our molecule will be named first. This will be followed by the more electronegative element, which will have the end of its name replaced with the suffix IDE. Due to trends in electronegativity across the periodic table, this will generally mean that the element with the lower group number will be named first, and if the elements are in the same group, the element with the higher period number comes first. Though these 2 rules of thumb with the period number and the group number will get us pretty far for naming molecules, it will fail us if we have a compound that's composed of chlorine, bromine, or iodine, and oxygen. in which case those elements will be named before the oxygen is. Next, we'll use Greek numerical prefixes to indicate the number of atoms of each element. However, we don't include the prefix on the first atom if there's only one of them. So now that we know these rules, let's try naming a molecule to get some practice. Let's take a look at this molecule, which is made of one carbon atom and two oxygen atoms. Carbon is less electronegative than oxygen is, and it's found in group 14 of the periodic table, while oxygen is found in group 16. So in both the name of this molecule and in our chemical formula, carbon will come first, followed by oxygen. And since there's one carbon atom and two oxygen atoms, the chemical formula for this molecule is CO2. And carbon will also come first in the name of this molecule, just like in our chemical formula. Oxygen will come next, but will replace the end of its name with IDE. Finally, we'll use Greek numerical prefixes to tell us how many of each type of atom are in the molecule. There's one carbon, which corresponds to mono, and two oxygens, which corresponds to di. But since there's only one carbon in the molecule and it's the first element that we named, we can drop the prefix mono, which leaves us with the name carbon dioxide. Now let's try one where we go the other way, where we come up with the chemical formula of a compound from its name. Let's try dinitrogen monoxide. As a quick aside, you'll notice that we dropped the double vowel here. We have monoxide instead of monooxide. This comes up fairly frequently when we name chemical compounds. From our name, we know that nitrogen is the first element in this compound. And since it has the prefix di, there must be two of them. Then oxide corresponds to the element oxygen, so that must be the second element in our molecule. And the prefix mono indicates one. But of course, we always drop the subscript 1 in our chemical formula. So that leaves us with the chemical formula N2O for the molecule dinitrogen monoxide. So that covers the basics of naming and identifying covalently bonded compounds. Now let's talk about the other major class of compounds we'll run across in chemistry, ionic compounds. Ionic compounds are composed of positively charged cations and negatively charged anions that are held together by attractive forces. When we were looking at molecular compounds, there could be many compounds that were composed of the same two elements. For instance, here are just a few of the compounds that can be composed of nitrogen and oxygen. But in ionic compounds, the cations and the anions combine in specific ratios to form a compound that's neutral overall. Since ionic compounds always combine in a specific ratio of ions, we won't need to use those Greek numerical prefixes. We'll simply have to work out the number of ions that are in one unit of a compound from the charges of the ions. Which means that we're going to need to know the charges of the ions in our compound to create their formula. So here are some common ions and their charges. Remember that elements tend to form ions that will have the same electron configuration as a noble gas. We will run across two main types of ionic compounds in chemistry. The first is the simplest, composed of only mononuclear ions. Mononuclear just means that the ions are derived from one atom. An example of this kind of compound is table salt, which is composed of positively charged sodium cations and negatively charged chlorine anions. We'll also run across ionic compounds that are composed of one or more types of polyatomic ions, which are a unit of covalently bonded atoms that have a charge. There are many polyatomic ions that pop up in chemistry. Here are just a few of them and their names. When we name ionic compounds, we'll always name the cation first, followed by the name of the anion, and we'll use the suffix IDE if the anion is mononuclear. So now that we know these rules, let's try naming some ionic compounds and determining their chemical formula. Let's go back to our example of table salt, composed of positively charged sodium cations and negatively charged chlorine anions. Since sodium is the cation here, we'll name it first, followed by the name of the anion, chlorine. But since chlorine is not a polyatomic anion, it's just derived from one atom, we'll replace the end of its name with IDE, giving us the name sodium chloride. Now we need to come up with its chemical formula. We'll need to make sure that we end up with an overall neutral compound, so the positive charge from the sodium needs to balance out the negative charge from the chlorine. Since the sodium cation has a charge of 1+ and the chlorine anion has a charge of 1-, we'll need 1 sodium ion for every 1 chlorine ion to make sure that we have a neutral charge. Since we just need 1 sodium for every 1 chlorine, we'll end up with the chemical formula NaCl for sodium chloride. Now let's try another one. An ionic compound composed of a positively charged calcium cation and the negatively charged polyatomic anion nitrate. Since calcium is the cation, it will be named first. And nitrate is the anion, so it will be named second. Since it's a polyatomic anion, we don't need to replace the end of its name with IDE. So its name would be calcium nitrate. Now we need to work out how many of each ion that we'll have in our chemical formula so that it has a neutral charge. Calcium has a charge of 2+, and the nitrate has a charge of 1-. We may recognize right away that we'll need 2 of the nitrate anions to balance out the positive charge of the calcium cation, which would give us a ratio of 1 calcium cation for every 2 nitrate anions. But if we don't see this right away, or if we're dealing with a more complicated ionic compound, we can use this trick to come up with the chemical formula where we swap the charges and use those as the subscript of the other ion. Either way, we'll need 1 calcium ion for every 2 nitrate ions, giving us the chemical formula CaNO3 But we don't want this to look like we have 1 calcium atom, 1 nitrogen atom, and 32 oxygen atoms in our compound. So we'll put parentheses around the polyatomic anion to make it clear that we're talking about 2 nitrate groups in our compound. There's one last thing that's worth mentioning before we move on from ionic compounds. You might notice that some elements can form multiple ions with different charges, like iron and copper. To differentiate between these ions, we can use Roman numerals in parentheses following the name of the element. So Fe2+ would be called iron 2, and Fe3+ would be called iron 3. This of course means that there would be 2 compounds containing iron and chlorine, for instance. But because the ions in ionic compounds combine in specific ratios based on their charge, we should be able to work out which cation we're dealing with based on the chemical formula. So now that we've learned all of these different rules for naming compounds, it's worth mentioning that some compounds have names that just don't follow the rules. For example, there are many compounds that have common names. We've already run across one of these. H2O is always called water and not dihydrogen monoxide. Similarly, NH3 is always called ammonia and not nitrogen trihydride. This happens most often for compounds that scientists discovered a long time ago, before we standardized the convention for naming things in chemistry. Another example is the compound TiO2, which is commonly found in sunscreens. Ti is the atomic symbol for titanium, which is one of the metals that can form multiple ions with different charges. If we work out the charge on titanium from the chemical formula, we would find out that titanium here has a charge of 4+, so this compound should be called titanium 4 oxide. And while some people do call this compound titanium 4 oxide, if you look on the back of your sunscreen bottle, you'll find that this compound has the name titanium dioxide instead. But despite this, many of the compounds that we'll come across in chemistry will follow the rules that we've learned in this video. So now that we know all these rules, let's look at a couple example problems. how many hydrogen atoms are there in a molecule of methane, CH4? This is the chemical formula for the molecule methane. The chemical formula tells us the type and number of atoms that are in one unit of a compound. We indicate the type of atom using the atomic symbols for each element found on the periodic table, and we indicate the number of each type of atom using subscripts. So from the chemical formula CH4, we can tell that methane must contain carbon and hydrogen. If we look at the subscript, carbon has no subscript. This is because, by convention, we leave off the 1 in the chemical formula if there's only one of an atom in a compound, so that means that there is one carbon atom in a methane molecule. And we can see that there's the subscript 4 next to hydrogen, which means that there's 4 hydrogen atoms in methane. This question asked us how many hydrogen atoms there are in a molecule of methane, and as we just discussed, there are 4. What would the name of a compound containing 1 atom of chlorine and 2 atoms of oxygen be? In this question, we need to name a compound that contains chlorine and oxygen. Chlorine and oxygen are both nonmetals found on the right-hand side of the periodic table, which means that the compound that they form will be a molecular compound. When we name molecular compounds, we name the less electronegative element first. Then we'll name the more electronegative element with the suffix IDE. Finally, we'll use these Greek numerical prefixes to indicate the number of atoms that we have in a compound. Chlorine is less electronegative than oxygen, so we'll name it first, followed by oxygen. But we'll have to replace the end of its name with the suffix IDE. Finally, we'll use Greek prefixes to indicate the number of atoms. We have 1 atom of chlorine, which corresponds to mono, and 2 atoms of oxygen. But by convention, we drop the prefix if there's only one of the first element. So we would drop the mono, leaving us with chlorine dioxide. Now let's sum up with the key points for this video. Chemical formulas indicate the type and number of atoms in a compound using atomic symbols and subscripts. If we have more than 1 unit of a compound, the number of units goes in front of the chemical formula. When we're naming molecules, the less electronegative element will come first. When we're naming ionic compounds, the cation is named first. Roman numerals are used to distinguish elements that form multiple ions.